Welcome back to Force and Motion. This is the next problem. It's a motion problem, and it's number 8. Okay, we're given a velocity versus time graph, and we're asked which of the following is true. So that means all the other 3 are not true. So sometimes when you're doing multiple choice, it's easier to eliminate the ones that are not true. And let me show you what I mean. Okay. So velocity versus time, let's just go through them. And the idea is, which one of these can we quickly eliminate? A, the object is not moving from t equals 4 seconds to 10 seconds. So we go from 4 seconds to 10 seconds. It is moving. It is going at 10 meters per second over that. So that is absolutely a false statement. B, the object's initial and final position are the same. Okay, so as we discussed in the earlier problem, area, so on a velocity versus time graph, the area is the displacement. And at a glance, I'm looking at, okay, that area. Okay, so basically if it basically comes back to the initial and final position, that meant it went somewhere and then came right back. And so what I see is that there is some positive displacement, motion in the positive direction, followed by motion in the negative direction, and I frankly cannot tell at a glance whether those are the same or not. And I'm asking myself, wow, this looks a little bit tedious. Trapezoid, I mean, we can definitely get the area, but do we want to take the time? Well, we will if we have to. So I'm going to say B is, I don't know. It could be true. Let's look at the other 2. And if we can eliminate the other 2, we know B is the answer. C, the object is slowing down from 14 seconds to 16 seconds. Okay, so 14 to 16 seconds is right here. Okay, so we're specifically being asked to look at that section of this velocity versus time graph. Okay, let me remind you, this is 0, and this is going faster and faster and faster. Negative velocity is not slowing down. Negative velocity just means you're going the other way than positive. And I see speeding up, speeding up. You're at 0, and then at the end of this period, you're at -5. That's called speeding up. So C is eliminated. Let's see if we can eliminate D. Okay, the average acceleration of the object from 0 to 4 seconds is different from the acceleration from 34 to 36 seconds. Different acceleration on a velocity versus time graph would mean different slopes. So what we're doing is we're looking at the slope from 0 to 4 seconds. Does everyone want to say hi to Leah? Hi, Leah.
Hello.
Hi, that's my daughter. Okay, so we're looking at the slope from 0 to 4 seconds, and then we're going to look at the slope from 34 to 36 seconds. And guess what we can see without actually calculating the slope? I see 2 parallel lines. And parallel lines means the same slope, which means the same average acceleration. So guess what we just did? We picked B without having to eliminate, without having to actually calculate the area. So we saved time. Now, if you don't believe that, you should definitely calculate the positive area, and you should definitely calculate the negative area, and I am pretty sure you're going to see that this plus this equals 0, which means you came back to where you started from. So the correct answer for number 8 is B. Okay, number 5. When I first saw this question, I was looking, oh my gosh, it's hard to say. Is the cart going, is down negative x or is down positive x? And is the car going this way or is the car going that way? And then I realized there is actually, the ramp has nothing to do with this problem. In fact, it's probably more of a confusing, it makes things more confusing. So let's just focus on what you're given. You know the acceleration is it's not plus, it's 0.5 in the negative x direction. So we know acceleration is going to be negative. That doesn't mean it's speeding up or slowing down. It just means it's negative. We'll find out later what that, how that applies here, because acceleration, negative acceleration by itself does not mean speeding up or slowing down. So you may recall we've made a few tables in order to kind of prove that negative acceleration does not mean necessarily slowing down. Okay, so what we see then is at the beginning of time, we have some positive initial velocity of 2 meters per second. And we're asked, what is this thing doing from 5 seconds onward? So let's make a quick table of values. Now maybe you don't have time to do this in a test, but we do now, and you could just kind of do this in your head. Okay, the key thing is that every second I'm going to change the velocity by negative 0.5 seconds. Then I'm going to ask myself, okay, what is this thing doing over time? Well, it starts out at plus 2. Add negative 0.5, it goes down to 1.5. Another second goes by. Add negative 0.5, goes down to 1. And keep going. And you're going to see that at 4 seconds, this thing has no velocity. Those are my dogs barking. Negative velocity. Okay, I mean, at 4 seconds, it's basically not moving at that instant. Okay, well, what's it going to continue to do? We're going to keep adding negative 0.5. So at 5 seconds, it's basically used to be going positive, now it's going negative, and guess what? At 6 seconds, 7, 8, it's going to basically be, you can see that it's speeding up in the negative direction. So let's see. Okay, I see this is the only one. Negative x direction speeding up. So the answer to number 5 is D.